I am Newbot. Good morning, everybody. Who all is here and has questions for Mewbot? Brian left. No one is here. Mewbot sees 14 people watching. Yes, Cooper. Hello, Sam. Hello, Kirsten. Good to see everybody. 1,000 points. Yes, must give Mewbot overheating from too many points. Mewbot out.
Oh my god, Mewbot's giving all those points. Hey everybody, what's up? I sent Mew code on Discord. Can you please take a look? Yeah, KP, let's take a look. You must have just sent it. Yeah, let's take a look here. Ah, yes. Now remember, code block. Whoops, I did it wrong. I don't even know how to do code blocks. Code block. If you do, here, I'll send you a picture of this. So KP, I'm going to send you a picture. This makes it all nice and neat right here. So code blocks. Check this out. If you do it like this right here, KP, it turns into a code block, which is super good. Super nice. This is my first code. I'm not going to error because I'm getting the wrong answer. Can you please take a look? Okay, you have the amount. Let's put on a little music right here, and then we'll start up some questions. So good to see everybody here. Let me see who's in the chat. I'm looking at KP's message right here. Hey, Gustavo. Hey, Vanish. Hey, Sierra. Hey, Hannah. Who's got questions? I've got answers. You've got questions. I've got answers. So good to see everyone here. Rajav, good to see you here. 474 homework is due tomorrow night. That is correct. We moved it to tomorrow night. Tomorrow night. Make sure to take a look. It's running but giving wrong answer. Let's see right here. So send me just... Okay, but I think you're doing amount minus... Do it outside the loop. Send me the code outside the loop because you have MP, amount, mortgage amount, rate, and I don't see the rate. So do it, try this, do it outside the loop. Where can I find review material for exam 1? Review 1. Whoops, I typed it wrong. Review 1 right here. There is review 1 right there. Mewbot is putting it in the chat. And also on Canvas. Let's go over here. Check out some Canvas. Review material for exam 1 or exam 2 or exam 3 or exam 3. There's no exam 4. The review material can be found under modules, and I should be doing some grading probably tonight for Stats 101. Grading. Let's go ahead and check this out. So here is where the review material is at. Also, Mewbot put the link in the chat. 474. Good question. Can the plots just be a regular plot with titles, or should they look nice? As long as they have titles and stuff, that's gonna be like the big thing. Like if you use base R, that's fine. Noah, good to see you here. If you use like base R functions, that's okay. You just want to make sure you have titles and everything. So here's where the review material's at. We'll talk about some plotting in 474. Let's do that. Doing some plots in 474. So BAS 474. Making good plots. Kind of talk about what makes a good plot right here. Harry Potter, this one makes a good plot. Let me close out everything. Closing out everything. Don't save. Been grading a lot today. A lot yesterday. Almost caught up on all the grading. You're welcome, Matt. Thank you for asking. Let's start at 100 points right here. Been grading a lot. And so 474 is pretty much all caught up. 201, you should be caught up soon. And 475 is almost caught up. My grader's starting this weekend. Woo! Grader Daniel. Good to see you here, Daniel, in the chat. Make Daniel a mod. Okay, let's check this out. So if you have, like, this is going towards the recent assignment, which wants you to plot stuff. So let's say we just have loan amounts. Now, this is not what your like how you'll create your vector. Does that make sense, Sierra and Matt? I'm trying to think who else is in the class. You have like a loan amount that's decreasing, and here we'll do a few more right here. Oh my god, we can't do that much. We'll do well, this is while. Let's go amount. Loan amount is $10,000, and while loan amount is, and let's put current amount. There's a little bit of help too. Current amount. This does not have interest. A lot of people have not put the interest. Bunny's in the chat. So let's go to current amount. Store into position 1. the loan amount, while current amount, while tail 1 of current amount. Okay, what does this find? I want you to think of a vector, and I want you to think of what this code finds right here. All those bunnies in the chat. Oh my god. Morty and Jolly are super happy about that. So what I'm glad people like my random things that Mewbot puts bunnies in the chat for you. What does that find right there? 474, 475. What does the code I've highlighted find for you? It says tail current amount, comma 1. The last number in the current amount vector, right? So while the last value, oh, we don't have anything stored in it. While the last vector of current amount is greater than or equal to 0. No, greater than, greater than 0. Because if it's equal to 0, it should stop. So while it's greater than or equal to 0, then we want to run the code right here. Current amount, and we're just going to do current amount, position, next position will be saved as current amount minus, and we're going to do a, current amount, current position. Current amount, current position minus the payment I'm going to put of, let's say, $367. Okay. So this is not quite how to do it, but it's a good example of like using a while loop to just run this and create this vector. But there's one problem here. And what is the one problem that you're going to run into with this while loop? What is the problem? Who can identify for 100 points the problem with this while loop? Tool 1, if you have questions. I know chapter 7, if people were asking about that, we could do a chapter 7 after this, like the SAT problem, the drug problem, there's a problem on drugs, the wildfire problem. Name those problems in the chat, 207 if you want to do them, or 201, and 207 is another class I teach. 201 if you want to do one of those chapter 7 problems. Chapter 7 is tough. Cooper, drop one of those questions in the chat, and we'll do it next after this. You got it. Wildfire, standardized test problem, SAT problem, we did the burger problem a few days ago. I do have videos on each of them, but we like doing them live here and walking through. It doesn't change. I doesn't change. Exactly. The placeholder I doesn't change. So we're going to start I right here as 1. So that way when the loop starts, I is equal to 1. And then this becomes 2. And then we're taking what is in position 1 and subtracting this much and storing the new value here. Now we need to go here. And Kirsten, that is excellent work. Great job. That's a mistake I've made. So now we need to go I plus 1 right here. Now let's take a look. All of this to get this vector. Now you could put, what you could go is you could take tail and go here and say, no, we could go tail of current amount and take the last value. And we could say overage. And we could actually go to overage and overwrite overage with, and I'll tell you why I'm doing this, -1 times overage. Reason being is this is how much someone has overpaid. Does that make sense? Like at the end of our installment of paying this, we have no interest. Make sure to put interest on here. That's one thing I haven't been doing with these examples. Because I don't want to do everything. I want to show you like, okay, that's how the while loop's doing it. You need to kind of have a placeholder that iterates. And so with this, do we upload our note cards? Yep. By Friday at midnight. Thank you, Cooper. 100 points. Great question, Cooper. Make sure to upload the note cards for the test 1 material by Friday, since that's when the test closes. Cooper, great question. So this right here is telling me how much was overpaid at the end of the loan. So we can take this and we could put it into our function and do cat paste. Now this is going to print whatever I put to the screen right here. So whatever I write right there goes to the screen. And we could say you, got to put in quotes, you have overpaid by, and then we put a comma because now we're exiting a string being a word, a phrase, a sentence, and we're going to put the object overage. So it says you have overpaid by this. How's that looking? And Sierra and Kirsten, there's Kirsten. Yep. Can someone drop the link to the update R in the chat? To update R, like how to update R. You'll want to re-download R. To update R, you want to re-download R. I've got a video on that. And now we're going to plot this vector. That's kind of our goal right here. So it's a little bit on while loops right there. So let me change the first thing. Making a while loop. Oh, I didn't put the time on this. What am I doing? Let me throw you the link right here. And if you have chapter 7 questions to 1, let me know. Getting started in our playlist. And here is the installing R video right here. So I should make this a Mubot link. And here it is right here, William. How to update R. There it is. Yesterday during the questions towards the end, where we were talking about interpretations of R squared and writing the regression, I was tech confused. Can you go over this some more questions? Yeah, Michelle, let's do that here. We'll do that here in a moment. You bet. So we're going to do this next section right here. And then we'll do Michelle's question on interpreting regressions. That's good stuff. So now we're doing the making good plots. Okay, and then interpreting section 1, interpreting regression. So tell me, what is the easiest way? Does anyone know the easiest way to plot the current amount the loan is at? What is the easiest way to plot the current amount the loan is at? Yeah, Vinish, well, the quiz has like tons of questions. There's like 20 questions. Vinish, let me know which one you want to go over. And KP right there, you are correct. We're going to go plot, and this is the easiest way to get it. Now, this is all right. Like, this is okay, but you need to make some updates to this. You might want to, like, if you're just using plot, you want to go here and go main. That's the argument to change the title and say, don't just say my title. You want to make sure you have a title there. And then I think the other arguments are xlab equals xlabel. There's the x label. And then the y label is ylab. I don't use base R much, but make sure to put these in and describe them as follows. This is okay. Like this, now, if you put the titles right here, that gets the job done. But what I'd preferably would do, like I would want to make a really nice scatter plot. So we're gonna look at the GG scatter plot, and let's think about this. We're gonna go to GG scatter plot, which I do have GG scatters in pub R. Let's try to take a few minutes right here and make a really good number. So tell me what it's about. The quiz changes. Finish. Thank you so much. 100 points. The quiz changes for each person. So your number 4 on the quiz might be completely different because it's randomly sampled from questions that we have. That's the random music. Be like, oh, it's the like the SAT question, the standardized test question, the wildfire test question, the calories and fat question. There's a lot. There's a lot. And then I'll find it right there and we'll do it next. Or we have a few more. We have regression talk, and then we're going to do the question there. You got it. So library ggpub-r is how we make really good graphics pretty easily. It uses gggraphics, which stands for the grammar of graphics. And with that, I'm going to go to ggscatter. Now, I haven't used ggscatter a lot. So what am I going to put? Because look at all the options. Holy mackerel. What am I going to put before this to help me learn how to use it? And this is a great thing to know, is like how to get help. So what am I going to do? Because Brian's like, I haven't done a lot of GG scatters. Dang it. Shrey, you got it right there, 100 points. We're trying to do as many things as we can do. If you notice, a lot of these arguments, and we're doing functions, a lot of these arguments have what's right now. A lot of these arguments have what's. So look at this right here, where it says it's equal to norm, or equal to 0.95. A lot of these functions, arguments, a lot of these arguments have what's. Like shape is 19, defaults. So there's a lot of defaults, like you can change the shape, the merge, the size. So there's a lot of defaults that it's going to pick for you, so you don't have to pick everything. You just need to put in the required parts of the arguments. And let's take a look down here at one of the general forms. They're using the mtcars data frame. They're turning it, they're making a factor. We're not going to deal with a factor right now. They got weight and miles per gallon. Cool. So this is your data frame. This is the name of the variable. And they're doing a really complicated thing, but that's going to be really interesting. So this looks like a lot, but we just have to know their format. And they're adding a lot of comments. They have a data frame. And let's take a look. They make it right here. They have a data frame. It's just the mtcars data frame. Okay. I'll show you. That's all that matters right there. And the way it looks is the following. So we need to take and have weight and MPG as 2 vectors in a data frame. Does that make sense? But we have just one vector right here of the current amount. What should we find out from current amount right here? This is kind of the last big question, then we'll be able to make our graphic. Because think about what we need to plot it. We would need how many whats there are. Think about what would go on the x-axis that we're going to put into a data frame, and we should be good then. Because we have the y values. These are all the y values. So you can almost kind of just tell the answer. Yeah. Can you tell the answer of what we'd need in our data frame? We need to make a data frame where we have right here data.frame. And the data frame is going to have in it our vector. And this will be called, let's call this data equals this. And then inside of it, we'll also have our what. What will we also have? There's a big question. This is probably the tough part of this. Because once we get this, we should be good to go. And it should make a pretty graphic, I hope. What do we need as our second variable? So here's the first variable. There's the y. We're interested in current amount. This is actually kind of doing regression right here. This is the y variable of interest, current amount. And then we would also need a vector of information for what? So we could actually call, if we think about what this represents, if we're paying something off, it might be good if we call it a certain variable name. What do you think? Time works right there. Riley, great answer right there. Time works. We could call it, I was thinking months or something like that, because if we're paying off by months, it could be month. Yes, here, exactly. Another 100 points. Months, time, something like that. It's the index of what we got. So one way to do this is go 1 through 29. That'll give us the right sort of data frame right here. And there's the data frame right there. But if you want to do it based on what you get, you want to go 1 through the length of current amount. The length of current amount is 29. So that just tells you how many elements. Is this 474? Is this making sense right here? How are we doing? I know I've written a bunch of code on the screen, but I've just made a data frame of 2 values. The current amount is what data is. And then 1 through the length of current amount, which is 1 through 29, is the amount of months. I'm basically replicating this right here into a data frame such that I can take the data frame and then go right here and say we're interested in the current amount. And then the months is going to be the x variable of interest. And then we get right here. Oh, what did it say? Oh, I think it's trying to do a character. Let me see right here. Error in use method rescale. Oh, are they characters? No. Number and integer. Oh, is it mad about... Let me look at this code again. Because I thought that would work. X equals weight, Y equals MPG. Oh. 100 points for the error. 100 points for the error. I see it now. What's the error? If only there was a text box. I know, right, Seth? You see it? I'm trying to hint at it to be like... I can say it, but I want you to see it. Give it another second. Yep, and it'll be in quotes. It always gets me that they put these in quotes. I don't like that it does it that way, but it should be data. That's what I called it. That should fix it. Boom! We got it. We need an offset on that. Because of the way... I almost really like this. We might actually take away that whole text thing right there. Coefficient arrangement. It's really cool that it does all that. Let's put F right here. There we go. Okay, cool. So I basically just changed correlation coefficient to false, and we get this right here. Color. Let's go purple. Size or shape 19. There we go. Size 5. No. All these changes you can make. All these changes you can make right here to make the graph how you want. But we're missing what still? What are we missing on this right here? We're almost done with this. What are we missing? I don't know about that. What are we missing on this? Because right now this does look a lot prettier, but what are we missing? What are we missing? We're missing one major thing. Missing one major thing. Title. So plus, and then we go here, GG title, and we say my title, and there's your title, and then we can go plus easy center title, and there's your center of your title. And if you want, you could go, we do it back here, and we could go to theme, and we've got a ton of themes. Make sure these are loaded up. You could go to theme. We always like this one, right? Change the theme. Yeah, it's not actually that bad today. Change the theme and see which one you like and get a good screenshot of what it looks like. Looks kind of like that right there. Can we use the same code? Yeah, let me drop this. So I want you to write that code, but most of this code was taken. I'm going to put this in the 474 Discord. So in the 474 Discord, go check it out. And we're about to do some 201, so 201, get ready. So 474 Discord, dropping some code right here. With the, make sure you probably have to watch this portion of the video. That way you understand how the code works. But KP, yep, you could use this right here, and then you'd get this really great graphic. Then you could store the graphic into the object P. And then all you have to do to make the graphic is do what? If the graphic's been stored into the object P, all you have to do to make the graphic is what now? The graphic's been stored into the object P. So now all you have to do is do what now? How do I produce my graphic? All that code, every single bit of code right here, all this code is now this. So what do I do to make the graphic? Because this whole thing right here is this. Close, KP, 100 points. Close. That might actually work. We'll try it. I don't know what that's going to do. It did work. It did actually work. And then Shreya's right. We could actually ggplotly it if we want. But you could also only just write P. If you write P, that works too. And then Shreya's pointing out how to ggplotly it. Make sure ggplot is going. And then it might look all pretty. Let's hope. There we go. Interactive graphic. And if you like it, you can screenshot it like this. But you can see exactly where you're at. You can see the model. And you can even zoom in on it. That's why we love the ggplot. Or ggplotly. But big fan. I know, Shreya, right? It's harder to make plotly objects. But once they made the ggplotly thing, I was like, oh my gosh, these are so easy to make. You just make a ggplot, and then you just toss it into a ggplotly. Ggplotly is one of the best functions ever. All it takes is a ggplot object. So we love the ggplotly function because you just take your ggplot object and throw it. So this ggplot object, and then you ggplotly it. So it turns the ggplot into a plotly. Hannah checking out. Oh, I think Hannah made the typo by accident. Hannah, that came from a student making the typo a while ago, and then we put in that secret message right there. So the pointer, Mubot tells you how many pointers you have. There's also, and then let's do some 201, pints. Student said pints, and then another student said pint hype. So let's head back to the main screen. Great work, everybody. Having some fun in the chat. Okay, random. All these different things. Having some fun. You have to do exclamation mark pint. So because it was a student misspelled points. So we've kind of made jokes around some of the stuff with pints and pointa and from the different things. Okay. Australia. 100 points, everyone. That was so fun. Oh, lag, yeah. Oh, Shreya knows a bunch of the secret commands. The joke is my brother Darren's always messing with our internet. I fixed a lot of those problems. If you've noticed, if you've taken the classes over a longer period of time, I've made a lot of fixes so that we don't have those lag bursts anymore. I changed the reconnect time so in OBS so that it pretty much tries to instantly reconnect, doesn't wait 5 seconds. Okay, let's do some regression and talk about what you need to know Stat 201 regression. If you have a question from the My Pearson, oh, that's Shreya. I'm so proud of you. You're doing excellent. You're doing great, and just happy to have you here. So if you have a question for My Pearson, let me know. Let's do test 1. Interpreting regression. Okay, let's do that. Oh, here we go. 25. Here we go. Stat 2 interpreting regression. Okay. Now, what do you care more about? We're just doing kind of a My Pearson problem right here. Now, Jump is going to make this really easy. Thank you, Michelle, right there. So I'm glad. We've done a lot of programming on him. If you go to a restaurant, you really care about the what and what you're eating. I mean, it depends. Are you on like the Atkins? What are you doing? What are you doing? What do you care about? You walk into that restaurant, you say, I'm looking over this menu item, and it only has, like, I want to know this from it. I want to know this. And you only got two. Do you want to know the fat or the calories? There's multiple choice. There's numeric entry. There's true, false. So it's just like the Canvas content. Great job, Rajay, right there. It's just like the Canvas content. That's how the best way to know what the tests look like. What do you care about when you walk into a restaurant? Do you care about the fat in the menu items or the calorie in the menu items? You might say, I don't care about either. It really depends. Like, sometimes I walk into a restaurant, I'm like, I want to get so the calories, maybe, right? The calories. So the calories is what we're going to care about today. So we say, you know what? I walk in, I care about those calories. Now, if you care about the calories, is that your X or your Y variable of interest? If you care about the calories, is that your X or your Y variable of interest? The X is the explanatory variable. X, explanatory, it explains things. Y is the question, why is something happening? So when we think about a Y variable, we're saying, why is this happening? So it would be the Y variable of interest. So what we do is we go over here to analyze, fit Y by X. This is a bivariate way of looking at things. And we ask, does the fat in the menu explain calories? Because we've gone to a restaurant apparently that only tells us fat. So we go to the restaurant, we open the menu and it only says fat. And we're like, what kind of menu is this? And they're like, oh, we don't report calories. We only report fat. So we're looking to see if think of an A word, a what between fat and calories. Like we were like, well, let me use my statistical knowledge to see, is there think of an A word, tells us if something lets us know something about something else between fat and calories. Because we don't know, association. So are these things associated? Like if I know the fat, would that give me information about the calories? And so we make the following graphic right here. And what do we see? Oh, it's on the other screen. Sorry about that. Went over here. Jeez. There we go. What do we see? Who sees it? What do we see? It looks to me like there is we haven't finished it yet. Looks to me like there's a what between fat and calories right here. Looks to me like there is a what between fat and calories. I swear there's a way to do the size bigger. Mark size. There we go. Oh, great job, Jessica. Positive linear relationship. That's 100 points right there. Positive linear relationship. I would say so. And now we can find out two ideas from this. The two ideas I would start to look into, think of a C word or think of, can we make an R? I always like try to let you think of the words. That way you remember them. We could look at the what between fat and calories. Think of the C word for it because we have two quantitative variables. Or we could look at making a what? Correlation and regression. Correlation and regression. The conditions for correlation are two quantitative variables. Fat is a quantity. How much fat is in the menu item in grams? Calories is a quantity. How many calories are in the menu item? So we have two quantitative variables. The next condition is straight enough. Straight enough means that a straight line goes through the relationship. Sometimes people think I say straight and up. The up and down, Rock knows the answer. It doesn't matter. It doesn't matter if it goes up or down. That's just the direction. This is positive, but what matters here is that a line well approximates the relationship. So QQ, two quantitative variables, straight enough, a straight line well approximates the relationship. If a straight line didn't well approximate it, it would look something like this. It would be bent like that, and then a straight line would not well approximate it. The last condition is we want no whats, because these drastically alter and can do anything to the relationship. The last condition is we want no what? No outliers. QQ, straight enough, no outliers. And then regression has one more condition. Those were the conditions for correlation. Regression has a fourth one that says the plot we are making should not do what? The plot we are making, which this one doesn't show this, and it could do it in any direction, it shouldn't get thicker. And it could get thicker or thinner. I think that's where people sometimes say, well, wait a minute, Brian, this one right here, I saw a plot on the test that looked like this, and this got thinner, so isn't that good? We want the strength to not be different throughout the plot. We want it to have the what strength throughout. So that one's actually pretty good over there. We want the strength to remain relatively what throughout the plot, which would look like this. We want it to be about the same. That's what plot doesn't thicken. This is a great one right there. So we want it to be relatively constant. Does that make sense? This is actually called homoskedastic. Homo meaning same, skedastic meaning spread. This shows homoskedasticity. You don't have to know the big word homoskedasticity. It's just fun to say. The other one is heteroskedastic, meaning differing spread. So a heteroskedastic plot is what we do not want to see, because this is symptomatic of plot thickening, where the plot gets weaker or stronger at different points, and then the summary statistics won't be a good measure of what's going on throughout the plot. So once again, those conditions that we were talking about right there are QQ for two quantitative variables. Fat and calories are two quantitative variables. Straight enough, representing that fat and calories have a straight linear relationship. No outliers, meaning there are no extreme points that pull the regression in some crazy direction. And finally, the fourth condition, plot does not thicken, meaning that it remains about a constant spread throughout. And these are, I understand sometimes we say, can we look at how to find the equation for the line of regression? Great question right there. Now, here's a really good thing to know. When you are doing, let me see if I have it open. When you are doing my Pearson work, well, let's show it on the, yeah. When you are doing the my Pearson work, I highly suggest using jump or the regression solver that I've created. So this is the regression solver. It should be all right here that I've created. So do not solve them by hand. Do not solve them. So you see right here, the regression solver 3.1. I need to upload the 3.2 version. It's just a little thing I've made in Excel to help you solve them without having to do them by hand. They can also be done in jump, but sometimes it gives you the summary statistics. So if you're doing one of those SAT problems where it says like the standard deviation of verbal is 58. Great job. Yeah, thank you, Daniel. This makes it really easy because it says like the correlation is this, the standard deviation of it is this, and the mean is like 650 and 540. Well, right here, here's the intercept, here's the slope, and then you can input a value like 800 to make a prediction for what something would be. So this is how I would highly suggest doing the very hard SAT problem when you get to solve the equations. You can solve them by hand. We won't have you do that on the test. You will not be solving for these coefficients right here on the test. Nope. Vinish, great question right there. You will not use this on the test. Hence why I made this right here to make it easier, because I don't want... The reason I made this is back like 6-7 years ago, I'd go to Stat Lab and a student would spend 20 minutes just solving equations or like trying to get things to work, and they didn't carry a decimal. So I was like, let's just put it into Excel, and then you just put the numbers in. And then the bigger point is to interpret it. So that's one of the things we stress in our class. It's not about the math. It's about what are we doing? Like, how do we apply this? Because we do business with business school. And so with this right here, we need to fit a line. Now, a line has two estimates. A line is going to have an estimate for the what and the what. The line is going to have an estimate for the what and for the what. Down here. The line is going to have an estimate for the what and for the what. Slope and intercept. Great job right there, Daniel. The slope and the intercept. So you see how this is 187.2? That is the intercept. And I think this is what drives people crazy. Okay. Don't do it to me. What is the equation of a line if you say like y hat equals... Don't do it to me. Don't do it to me. What is the equation for a line if you say y hat equals? Algebra has taught you wrong. What is the equation of a line if you say y hat equals? It's all right. I'll live if you do it. Oh no, Michelle! Michelle, 100 points. Classically, you learn mx plus b. That's the classic. Everyone kind of learns that to start. In statistics, I'll show you what we do. In statistics, Michelle, 100 points for laughing maniacally right there. B0 plus b1x. So in algebra, and this is going to look a little odd, it's mx plus b. So there it is right there. Now, if you look, the x variable is fat, and so that's why that's over there. That's mx plus b. Does that make logical sense right there? But here's the thing, really, why I like calling it b0. Why, if this is b0, which b stands for a coefficient, that's what a b is. Not in the algebra sense. Like b, I guess, is a coefficient in algebra 2, maybe? I don't know. I don't talk algebra. I talk statistics. B0 is the coefficient of the intercept. So we have right here B0. And think about this. B0 is when what? Just repeat the sentence. Finish it in for me. B0, which is the y-intercept, is when what is what? Just think of what we call it B0. Because if you were to say, oh, that is 0. So B0 is what? When what? When bunny? B0 is what? B0 is what? B0 is the value of the y-intercept because it's when B0 is when x is equal to. It's the y-intercept because it's when x. B0 is 187.2 because it's when x is equal to 0, right? So when x is equal to 0, the value of the y-intercept, great job right there, Sam and everyone. So that is B0. It's when x is equal to 0. And think about why we call this then B1, because it's B1 because on the line here, it's for each what of x. So it's B1 because it's for each one. Think about B1, each 1 unit. I want you to finish the sentence. You're like, oh, B1 is the slope because it's each 1 unit increase in x. So that's a really good way to remember it, is B0 is when x is equal to 0. That's the y-intercept. B1 is for each 1 unit increase in x. Now, remember, the slope can be negative, so increasing x might decrease y, not cause and effect. And so we're kind of preparing for the test. Here are some, if I am to offer you some super help right here, if I am to offer you the best help in the world right now, sometimes we have some really big teaching to the test moments. My brain is rested. I'm ready to go. Here we go. What is a bad word we do not say in statistics? Bad words. Bad. These are banned words. Cause, prove, know. Those are probably like, I know this causes this proves this. Causation, exactly. Causation, great job, Isabel, right there. We don't say things cause things. We don't say we've proven something. We don't say we know something. I mean, know is a little bit like, I mean, I say I know things, but oh, I know that the slope is this. But I wouldn't say we know that we will get this. Like, it's a little correlation cause. Ooh, Jessica right there. Yeah, we'd never say correlation causes causation. Like, correlation is not causation. So you can't do that. You know what's really interesting? What if the correlation was 1? What if the correlation was 1? Wouldn't that be like, whoa? So if the correlation is 1, is that really good? Watch this. How easy is it to get a correlation of 1? If you only have 2 points, so R is correlation. If you only have 2 points, and we can't even see those 2 points for some weird reason, we're going to retry this. If you only have 2 points, second try. What in the world? Okay, let's try this one more time. If you only have 2 points, you will always have a correlation of 1 if correlation is calculable. So if you only have 2 points, you will always have a correlation of 1 when correlation is calculable. Wow, it's just clicking all over the place. Well, we'll worry about that later. But you'll always have a correlation of 1 or negative 1, excuse me. See, even my brain's got to boot up a little bit. If it goes, I was trying to go up, but you'll always have a correlation of 1 or negative 1, and then R squared is what? So this is a thing again. R squared is what? Or how do we get R squared? So I know it's R squared, but talk to me a little bit differently about it. R squared is what squared? I know it's R squared, but what's R? R squared is what? R squared is what? What is R squared? It's what? Correlation squared. Exactly. So be careful. You ready? Here's a trick. I'm going straight teaching to the test right now. Well, not like literally, but these are, whoops. These are things I've definitely seen on the test. You ready? Find correlation. Okay. Find the correlation here. We did this one last night, and I don't think I caught anybody. That says R squared is equal to 0.8. Find correlation. R squared is equal to 0.8. Find correlation. R squared is equal to 0.8. Find correlation. I should have done it first. R squared is equal to 0.8. Find correlation. So what is R equal to? We might catch someone on this. And then you'll be like, oh, and then you'll remember for the test. Sam, you're so close. Sam, 100 points. Cooper's so close. Who wants to catch the error? Met, 100 points again. You are right. So look at what Met did right there and think about it. So watch, Met got it right there. Because what do you have to do when you find correlation? And then people are like, wait, what? Isn't it supposed to be negative? Exactly. People are seeing it. So this is, we want to get, yes. Well, Sam, you're going to get it right on the test. If you get a question like this, you're going to be like, okay, wait, if we're finding R from R squared, we have to square root it and then check the sign. So no, don't worry right there. 100 points, everyone's seeing it. It's going to be negative, and that's a big important thing. It's just we do it really quick. We're like, I got this, I got this, I got this. And then we forget to check to see if it's negative. So it is negative 0.89. So just a good kind of trick question right there. I mean, I guess trick, but it's just one of those things we forget to do. It's not like meant to be tricky, but it's just like, oh yeah, you got to look at the sign of it, the direction of it to know if it's going up or down. That's correlation indicates direction too. How about outliers and make a positive correlation negative? So I want you to answer true or false to these questions right here. So answer true or false to the following. You ready? Outliers can make a positive correlation negative. Positive, flat. Outliers can make a... Which of these is the true one? Which of these is the... are you seeing it? What do you notice of the theme of this? Can anyone explain? Outliers can do anything. Cooper, 100 points. Anything is possible with outliers. So what do we say right here? We don't like outliers, so we don't want them. So think about this theoretically. If an outlier can take your correlation and do anything to it, then your correlation is basically controlled by the what? If outliers can do anything to your correlation, like make the line go up, make the line go down, make it weak, make it strong, then when you look at the value of correlation, it's just being dominated by the what? So you're like, I don't like these. You got that. That's your face right there. That's you thinking about outliers right there. You're like, it's being controlled by outliers, right? So then we say QQ straight enough. No outliers. We say, you gone. We don't like you. So we don't want them because they dominate the correlation. And then the correlation is just kind of encapsulating the information from the outlier alone. So the outlier can create a relationship that is not indicative of the rest of the plot. And to exemplify that, probably one of the key examples would be drawing a plot like the following. If the graph had a positive slope, would the R also be correct? Sam. Perfect answer. Just what Sam said right there. If the graph had a positive slope, then correlation has to be positive. Super quick question. R squared equals 0.64 for this. What is R? So Sam's kind of doing a double check of his knowledge right there. So Sam, what would be, or anyone, feel free to answer, what would be the R right here? This is morning Brian with coffee, not late day Kahoot Brian. Morning coffee, Brian. Thank you, everyone, for all the positivity during the Kahoot. Sam, I told my wife, Sam, about your joke, and I showed her Mewbot going away. When Sam was like joking in the chat with our invasion of the bots, Mewbot was fighting off evil bots. We had to like reprogram Mewbot and make him stronger, more powerful Mewbot. So he fought them off. He fought well, and he went away, but he came back in a Stat 201 episode 2. He's back now. But yeah, you cracked me up last night. Sam was pretty good. So it is 0.8, and you square root it, and then you check the sign of it. It is positive. The idea of outliers doing anything is if you have a plot like this, what is the correlation right now of this plot? What is the correlation of this plot? So look down here at this, and the best way to figure out correlation is to do something like that. If it looks like a 1, it's closer to 1. And if it looks like that, it's about 0. Great job, Isabel, right there. So this probably has a correlation equal to about 0. Just guessing, because if it looks like a 0, if it has like this shape, it looks like a 0. Great job, Sam, right there. But now we put a point over here, and look what happens. Now the correlation is probably something like 0.9 or something. It can drastically increase the correlation. So every other point without that outlier has a super weak, non-existent correlation. But then when we add the outlier, it creates a relationship that's non-existent. The same that like would not be there had that point not been there. The same thing happens if you see a set of data that shows something like this right here. What is the correlation of that right there close to? The correlation of this without an outlier would be close to what? So that plot I've drawn right there has a correlation probably close to what? Like what would the correlation be right there? Probably closer to what? So just those 4 points, probably about what? -1. Great job, because we indicate the direction right here. So it's probably close to -1. It's close to a perfect negative linear relationship. But then all of a sudden you add in an outlier over here like this, and you see that it goes from a relationship like this to a relationship like this right here. And now the correlation with the outlier included is probably closer to 0. But there are questions that are a little tricky too on correlation and regression. We go back, talk more regression here in a moment. What about what's the correlation of this about equal to? So if you know the trick, do the trick, draw around it. And what's the correlation of this kind of close to? See, that's a weird one, Brian. It is? It is? The correlation of this is probably closer to what? 0. Great job right there, Matt. So there's no relationship here, yes or no? Let me say there is no relationship. Now, a relationship is like an association. Association means if you know X, you know something about Y. So the correlation is equal to 0. There's no relationship. Yes means you're saying there is no relationship. No means you're saying there is a relationship. So if you say yes, you're saying, yeah, there's no relationship there. Great job. I was really impressed by the Kahoot last night. I've been really impressed. I think people showing up here to office hours, I'm excited to see how people do on the test. And then I want to maybe send out some advice from people. But are people feeling pretty good about the test? Because people did well in the Kahoot last night. And I will say this, if you're new here, a lot of people have been showing up to these or maybe watching these, have been doing really well. Like, at least, like I'm seeing success, I'm seeing understanding, and like that excites me. So I'm really happy that you're here. I know the class is asynchronous, so it is a kind of learn at your own pace, but I'm really proud that people are jumping in, asking questions, and doing this. I do feel better about after the Kahoot. Nice job, Michelle. Yeah, and the test is still going to be tough, but here's the good news. The completion of the modules is worth more than any of the tests. Does that make sense? The completion of the modules is worth more than any of the tests. So if you do all the work, and I mean this truly, if you do all the work in the class, I think I've seen I wish I've done the data many times. I think it's something like 96% of students who do the work, and by do the work, I mean you do all the quizzes, you do all the homework, you turn in the projects, you turn in the visualizations, 96% of them make a B or better. And I think it's like 40% make an A. So you might be in that 40% that makes the A, or you probably will be, can't promise, in that 96% that makes a B. So keep doing all the work. And if you really fear stats, I hope a B is like, yeah, I made a B in stats. Not everyone will make an A, but if I've had students who, let's call him D, first name is Thursday. One of my favorite emails was from the student. I'm just going to tell us really quick because I miss so many of my students. He was a former professional soccer player, had gotten many concussions, and he just told me, Brian, I can't remember things. He's like, I'll do it, and I just can't remember it. And I said, okay, look, then you're going to get A's on everything. Like, come to office hours. We're going to do every quiz. We're going to do everything. You're going to get A's on everything that is not the test. First test, because we haven't named him, got like a 45 or 50. Second test, got like a 45 or 50. He said, Brian, I'm going to make like a C minus D in this class. I said, we're going to do everything. And the last test, I think he made like a 95. And I sent him an email and said, you made a B. And he said, yes. Like, it was this long, like, it was just one of my favorite moments. I have a lot of favorite moments of teaching. And to think that a student who made a B is probably the most excited I've seen a student over a grade ever. And he just worked really hard for it. And I knew he could do it. If you sat him down and he could do it, he just had trouble remembering things. And I just was like, we're going to do this. And yeah, so shout outs to him. He came back, and I actually have a picture he came to my office like 2 years later after like leaving UT. And he's just like, hey, can I take a picture with you? And I was like, sure, of course. He's like, can I put my arm around you? I was like, okay. I was like, sure. But shout outs to him. Anyways, story time with Brian right there. Gotta find that picture. Okay. So the answer is there is a relationship here. It's just not what. Correlation only measures the what. And then we're going to do more questions. Drop those questions in the chat. Correlation only measures what? Correlation only measures what? There is a relationship. Boom, Jessica right there knows it. There is a relationship. Correlation only measures linear relationships. So the relationship here is nonlinear. Jessica, everyone, what questions do you have? Let's knock out some more questions right here. Let's start answering some questions. I might even do a little more teaching with test material here. Since the Stat 1 test is currently open, let's take a look. Now, I know we did an extended period for this test because of my Pearson. A few people have wondered, the test 2 is extended also because of my Pearson. Test 3 I cannot extend because it ends on the last day of class. I can't. You two would be very, very unhappy with me if I extended the test like beyond the end of class. So we're kind of on the end of class for test 3. I'm adding in, I want to make sure I've added this in. I don't know if I sent it as an announcement, but I'm adding in another drop for test 3 material. So there should be 2 quizzes dropped. So basically that's my best attempt to kind of lighten the load. Yes, we have done it. There is 2 quizzes dropped for test 3 material. Test 3 material's pretty tough. We only get dropped quizzes, not homeworks. I added in a dropped homework too, Jessica. So we are not supposed to have a dropped homework, but I added in a dropped homework because of this. Does that make sense? I have a test question on average. How long is it students take to complete the test so I can set aside enough time? There is 90 minutes. The average is about 45, 50 minutes. Like it varies. So I would set aside the full 90 minutes. If you're trying to do it in a faster sense, which that's each individual's call, maybe 60 minutes, but you do have the full 90. But the average, I think, or I could look right now and see what you done the test. And thank you so much, everybody, I was just shocked I don't know. People are nice to me. The average time right now is 31 minutes, and the scores are pretty good, but it looks like there's very few. There's 1, 2, 3, 4. There's 7 people have taken it with an average of an 83. I think because that doesn't tell you who's taken it or what. Let me see what I should cover. What other questions are there right now? It's so short to see right here. I think it's very fair. There's a lot of, I mean, the grades right now are really good, which has me very happy. I can think of like how we've covered pretty much all of these. I'm just like scrolling through. I guess that's a lot of them are Canvas. Is anyone in here? You know, you can't say questions from the test. Has anyone taken the test yet? What are people's thoughts? I don't know if anyone's taking the test in here right now, but grades are pretty good right now. I mean, it's going to change as more people take it. And then it's not random individuals taking it. Like if someone's taking the test right now, it's probably not, they're probably saying, I feel prepared, you know, but that gives me a lot of confidence. Still to finish chapter 8. Yep. And we could talk about some chapter 8 right here. Let's do that. Jessica, would you like that if we do a little talk on chapter 8 and talk about the material for that? Because that is what you're currently covering. So I think that might be a good usage of our last 30 or so minutes. Well, 20 minutes. Going to start preparing for, wrong test. Let me go over here. Let me think about what you should be thinking about chapter 8 material. Give me a second right here. One more song in the background here while we get started. So chapter 8 is basically an extension on regression. Let's talk about those residuals. Okay. I'm good to go. Do we have immediate feedback on the I think you do. I'm 99% certain. Because the thing is, I don't see it. I think it's set up to be that way. So the answer is yes. Let's review more regression right here. 57, 40. Okay. Let's go over to the main screen. Nope, decision trees on the exam. Good question, Cooper, right there. 100 points. No decision trees. Let's go over to the main screen. Okay. You ready for an easy question? Here we go. Let's write a question right here. Stat 201 students plot their data and investigate whether studying increases or decreases. Investigate whether watching Brian's office hours increase or decrease their grades. Cats in the chat. And they find the following information below. Okay. So here's what they find out. The graphic looks like this. Okay. First question. Okay, so it's study, hours watched. And then this would be grade. This is not real data. Do monotonic lines split? I was like, who's wondering about monotonic lines? Monotonic. This is monotonic. Monotonic means one direction. Your favorite band, Monotonic. And so, yeah. Okay. Asking those jokes. Okay. First question is, what is R squared here? What is R squared? What is R squared? Find me R squared. What is R squared? Bring the graph back in. What is R squared? Great job, Michelle. So we just square R, right? So R squared is literally R squared. So we just take the value of R and we square it. that would mean 64% of the variation in someone's grade is explained by the hours they watch. So clearly watching office hours causes people to do well on the test. True or false? Watching office hours clearly causes people to do well on the test. That is very, very what? False. What? You're right. And just think about it. Explain to me, like, just go reasons. Like, why? Like, you could say, but people who watch office hours are doing better. Well, you can't say cause, right? And just think about, like, the issue with watching, not like it's bad to watch office hours, but it's like, I don't want to say it. I just want you to think theoretically about this, why it's like, well, we really can't say cause here because there's not random selection on who watches office hours, right? I'm trying to get a good size on that. There we go. There is ways to show cause and effect. I'm not going to get into that. We don't do experimentation in Stat 201. So there are ways to do that with random assignment and treatment and control groups. There are good ways to the gold standard of an experiment in research to kind of show that there is probably a cause and effect relationship by manipulating one variable and holding all other variables constant. Pretend I didn't say all that. But that's good to know because there are ways to investigate this. But with this right here, if you're in office hours, you might be like, okay, I'm going to study. I'm going to do all the work, blah, 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 blah. And of course, there are people who don't come to office hours to do great. I want to point that out. Like, you don't have to come to office hours to do great. But coming to office hours is not a random thing. Like, if you're here right now, you're probably wanting to, like, you're like, I'm going to do well. If someone's given up on the class, they're not going to be here. And then the grade's probably going to be lower, and that's going to go with it. Great job, Rajiv, right there. So that's a good first question right here. Brian thinks, can Brian use this to explain grades in his BAS 320 class? This is actually kind of real world for me right now because I kind of looked at hours. So can I use this? Yes or no? Or Brian can use this. True or false? False. Yeah, Brian can use this. This would also be false. I'd kind of be whatting my model in a certain sense. What is you're going outside of what the data was created from, although we usually think of it as if you're going outside this bound right here, this is another way of sorts to what your model. So if you're outside of the data your model was created from and you're not using it for its intended purposes, you're kind of whatting your model. Extrapolating, Sam, yep. And extrapolation in the most classic sense is when you leave the x-axis. So if someone said, what if I study 50 hours for the test? They'd probably guess that's extrapolation over here. Extrapolation. Here, we'll put the little squiggly spell check line underneath that. Extrapolation. I'll put it in the chat right here. Extrapolation. Oh, I actually spelled it wrong. Oh, I just forgot the R? Gotta be kidding me. It's in the chat right there. Extrapolation. I got it right. Oh, no squiggly line. Okay. So extrapolation is when you leave the x-axis. So the key word of this, or key part of this, is extrapolation. Extrapolation. So a person who said, what if I study 20 hours? Our model might predict they might make a what? If someone said, oh, what about if I study 20 hours? And this is why extrapolation sometimes can look really weird, is the model might predict they'd make a what? Just think about, like, theoretically, if someone said, oh, if I study 20 hours for the test, it says I'll make a this. And you're like, well, you're extrapolating outside the bounds of the X variable on what the model is, like a 200. So it's like, yeah, I don't know if you'll make a, that's not really the intended purpose of the model. So what if we did that down here? And so what two things do we need to make our model? What to draw this linear model, we need a blank and a blank. To draw this linear model, we need a what and a what. To draw this linear, a slope and an y-intercept. Great job, everyone. Good practice. Yep, we need a slope and an intercept. And the intercept is going to be known as B, and that's a sub-zero right there. Great character in Mortal Kombat. And a slope, and the slope is going to be B sub 1, not in Mortal Kombat. And so we have our intercept and we have our slope. And let's draw it. So if we had the equation, it might be grade, I'll put y hat, equals, and then what does the value of the intercept look to be about equal to? What is the value of the intercept? Just look at it visually and say, oh, when hours watched is equal to 0. No decision trees on the exam. Cooper, good question. No decision trees on this exam. When hours watched is equal to 0, then we'd expect somebody to make this. Now, we're not saying they will make this. It's the predicted. That's why it has a hat on the Y, because Y is your actual. You're welcome, Cooper. Keep asking those questions. You got them. So when someone watches 0 hours, we predict that they'll make this. A 60, yeah. And if you look right here, and you won't solve for that on the test, but looking at it, like there might be visuals or stuff, but we won't have you do the equations where you have to solve like the intercept by doing standard deviations and stuff. So that is 60, and that is the value of B0 in notation. And then we'd go here plus. And if you look at this, it goes up to 100, and it's almost at 10 hours. Like, we'll pretend that that was 10 hours over there. So maybe it's about a slope of 4. This is just estimates. And then hours. Well, there are some students who just don't follow the pattern at all. A student in the class never comes to office hours. Totally fine. Totally fine. Everyone learns at their own pace different ways. And they make 100 on the test. What is their residual? So let's put that question on the screen right here. Yeah. I do not understand. Sometimes will not let me text downward. A student never comes to class. They make 100 on the test. What is their residual? That is how we find residual. Great job, Jessica, right there. So a student never comes to class. Never comes to office hours. Jessica's getting, nice job, Jessica. Yes, yes, yes. So let's look at the work Jessica did right there. And we'll write the question for everybody to see. We'll do it on the next page. That way we have more space. So here's the question. A student goes to 0 office hours. And, yup, I think so. And they make a 100 on the test. What is their residual? Now, to find a residual is the formula. So E is residual, and it equals the actual, which is Y minus the predicted. Now, I like to say residual equals actual minus predicted right there, residual wrap. Can you explain? Oh, that was just an estimate right there. We wouldn't have to find that by hand. Good question, Matt. I was just kind of estimating it. You wouldn't find that by hand. We won't have you calculate the slope by hand on the test. So good question right there. So if you look at this, the 100, a student made a 100, that is their what value right now? If a student made a 100, that is their what value? So the student made a 100. That is their what value? We're going to highlight these things as we talk about them right here. That's what they actually scored. So Y is, and this is the actual notation right there. The E is residual, Y is actual, and Y hat is predicted. In kind of an easier understandable sense, R is residual, A is actual, and minus predicted. So that's what we say, residual equals actual minus predicted, but that's the statistical notation of it right there. So you will see like E as residual when you look at notation sometimes. Now we next need to know this. They went to 0 office hours. That is their what value. Just one letter in the chat. That is their what value. They went to 0 office hours. That is their value of what? And good for them making 100. Hey, if you go to 0 office hours, you make 100. Boom. I'm proud of you. I tried to make the modules as good as I could to help you learn the material. And if everyone could make hundreds and not come to office hours, I'd be like, awesome. That's not quite the predicted. Close, Matt. 100 points. That's not the predicted. So think about it. If we say 0 is the predicted, that means I predict they'll make a 0. So it's 0 office hours. So 0 is the value of what? Don't look down here. Look up there. So did they actually make a 0? 0 is the value of x. So we're going to highlight here. So 0 is the value of x. So what should we do with 0 now that we know the value of x? So we should just talk to me theoretically. It's like, okay, they went to 0 office hours. So now we would take 0 and do what right here? Does that make sense right there? We plug it into the formula. And then so very close. Met another 100 points. Not great. Oh, we're throwing a 500 points because Brian forgot something. It's not grade, it's what grade. And look at the bottom. Brian forgot a little symbol that is very important. That's not their grade. So Met, even I made this mistake right there because I did have it written grade. So 500 points for Brian's error. It's not their grade is equal to 60. It's their what grade is equal to 60. And look down there for the hint while we have a hat over it. So it's not that their grade is equal to 60. It's their what grade? Predicted grade. So they were predicted to make a 60. That's what the hat means over the Y. So if you have Y, that's the actual value. But when you do Y hat is the predicted value right here. So that's the predicted value from the equation. We have to solve for that. So then we would just simply take, well, we predict that they would make a 60. We subtract that from them actually making a 100 and explain to me in words what the residual means. And we'll view it here visually. Here would be the student right here. Explain to me the value. We'll highlight residual here. Explain to me what this residual means right here. And that is their predicted value, rather. And this is their actual. Explain to me this value of 40 and what it means that it's 40. They actually scored that. Wait, that is their. Oh, no. Oh, my gosh. They actually scored a 100. They were predicted to score a 60. The students scored what? Since their residual is 40, that is correct, but we actually reverse it. They were predicted to make a 60. They went to 0 off hours, but they actually made 100. So correct. So they were 40 points higher than we predicted them to be. Does that make sense? The residual is often talked about the distance it is away from the prediction. So they were 40 points higher than our prediction. So the residual being positive means they are 40 points higher than the prediction. A test question that I've wanted to write for so long is, would you like a positive or negative residual on this test? What would you say if I wrote you this test question? I've never written it. Maybe I'll talk to Terry and be like, we got to do this test question. Would you like a positive or negative residual on this test? You kind of get what you ask for at that point, because we'll help you out. We'll help you out. It should say, well, we want to help you out. Do you want a positive or negative residual on this test? So how would you answer that question? I mean, so maybe someone doesn't want positive for sure. And that would mean your score is higher than we predicted it would be. So we would increase your grade because we're going to make your grade higher, positive, because we were making higher than it's predicted. Yeah, exactly. That you're like, is this counterintuitive? You're trying to trick me here? Because if you say negative, then you should be lower than you were predicted. So we might have a student who is predicted to be over here, but if they actually are here, they would have a negative residual, and whatever this distance of E is would have to be negative. So they would be here. This would be you. Here, let me unhighlight a bunch of things. You. This is you. That's your grade. You scored lower than what you were predicted to score because the line predicts. So we could just take your score and lower it. But if you said positive, we could just take your score and increase it, and you would be above what you were predicted to be. You were predicted to be on this line, but you are above it now. We're going to increase your score. I've always kind of wanted to write that test question as a like interesting, you get what you ask for test question. Yeah, it's very well. Chapters 7 and 8 are very repetitive. This is a good representation, I think, talking about the residuals, talking about cause and effect, talking about extrapolation. I think like it'd be hard for me in like 20 minutes to like do everything, but I think we did, because I looked at the stuff on the test just a moment ago. I think this is a pretty good talk about the chapter that I could do in 20 minutes. Does that make sense, Jessica? I don't think chapter 8 is so bad. I think chapter 7 is the tough one. Like chapter 8 is regression wisdom, which frankly, if I were to rewrite the book, I don't write the book. If I were to rewrite the book, I would put chapter 7 and 8 together. 6 should be by itself. But yeah, chapter 8 is kind of an addendum. It's a easier chapter, not as bulky of topics. It's like, hey, here's a little thing. Chapter 7. I teach a whole class on chapter 7. I teach a whole class. It's so cool what we can do. Check this out, and this is why I love coding. We'll end with this. You saw earlier, if you're watching the beginning of Office Hours, we were doing some really cool plots. Oh, we're still inside of this, and it's probably going to say my data is not loaded up. But, end? Oh, no. Oh, this thing is totally broken. Finish. There we go. We were working on some data over here earlier, doing regression, and I don't have GG Pub-R, or I don't have library GG Easy. What questions do people have? We'll finish off with this right here. You guys know I love some R. Did you ask me about R, Matt? I think did it make? Oh, I saved it into P. There we go. Let's add that correlation coefficient back in. Hey, Carson, good to see you. 100 points. R is terrifying. Oh, no. R is fun. Because look at... We can make some really nice graphics right here. Like with the MT cars data frame, we could change this over here to data frame equals MT cars. MPG. Carson, have you seen there's a new Rugrats show? Carson knows what I'm talking about. So now look at this. We get... I don't like where that's putting it. Why is it doing that? That's weird. Oh, label X. Position 3, I think. There we go. Not too bad. There is our regression. Look at that. We even got the p-value on it. Yeah, well, I'll have to check it out. I don't know. See, it's so hard when you like go back. I'm all about those Nicktoons, only on Nicktoons on Nickelodeon. This is what we can do right here is we can add in we can make really good plots with especially R. All the colors, all the things you can do. We got here the value of correlation, all this stuff being reported, and we made this graphic earlier. But we can do a lot of investigation, a lot of really nice plots, put them in reports. Yeah, no, I'm excited. Carson, you came at the end. Let's throw some 500 points for a random appearance from Carson. Thank you so much, Carson. I hope you're doing well. Gosh, it's been so long. Oh, real world is fun, though. I know, right? 20... Was it the COVID semester? Was it? It was, wasn't it? It was then spring 2020, right? Spring 2020. Man, I was telling stories about former students today, Carson, and Carson was on the right side of the class, first class, wearing that Rugrats hoodie, and I was like, that's awesome. So good to see you here, Carson. And yeah, man, you know, if you got cartoons, it's all like awesomeness. Let's end off here with our fun video. Yes, it was. Yeah, there we go. I don't know. I'm so glad, Matt. So good to see you today. It's different being online a little bit, but I still get to know students. Oh, you're welcome, Jessica. Thank you, Jessica, for being here, using artwork, and it's crazy. Oh, well, Carson, you should come talk to us about that, like what you're doing with R, especially the Business Analytics Society. And I'm planning. Hey, Carson, check this out. I've already announced this. I sent an email out this morning about Does anyone know the Student Engagement Center in Haslam where it has like the big screen? Because I've got a dream, Carson. At the start of the semester, and Carson probably remembers this, I used to play Mario Kart. I think we did that in your class. We should have, because that's what I usually do. So what I want to do is, in the Student Engagement Center, have a business analytics event to start the semester, but have it be a Mario Kart tournament. And for like 3 hours, we bring in students and we have them play Mario Kart and we show them their statistics afterwards. You can DM me on Discord. Yeah, throw me a quick DM to remind me. Be like, hey, Brian, let's talk about it. Just throw me a quick DM if you can and be like, yo, Brian, you wanted to talk? And we'll start talking about this and we'll get some conversation going, doing some stuff. But I'm hoping we can get, I sent an email this morning to talk to someone about it, on the screen, the Student Engagement Center screen that's like a wall. Imagine playing Mario Kart on a huge wall. Like you're in like a, you're full, you got your little fourth of a screen for Mario Kart, but it's as big as you. The screen's just like this. So you can be like right up next to be like, yo, driving Yoshi. No. Ah! I'm gonna fall out of my chair now. You can't see Yoshi. You can't see Yoshi. Oh my gosh. That thing is 20 years old. Oh god. I'm getting old. Okay. Well, I'm gonna head off. I gotta teach here in a second. Carson, bye for now. Bye.
Hey Brian, what's up?
Hey Adam.
Oh, what's this?
Adam, what are you doing? Adam.
No!